Okay, I think everyone's in the room. Got our three speakers, that's the most important thing. So, hi everyone, good to see you all today, both here in person. We've got a good number of people here at the ATSE offices in Canberra, and welcome to the people online as well. This is the first of our ACT Division webinar events for 2026, and it's really good to see you all. Before going any further, I would like to acknowledge the Ngunnawal people, who are the traditional custodians of the land where we're meeting today, and I pay my respect to elders, past and present, and emerging. And I extend this respect to all Aboriginal and Torres Strait Islanders who are joining us at this meeting today. So today we're really lucky. This is something that I've been wanting to do since I took up the role of being chair, which is to find a window in the first quarter of the calendar year to welcome our new ACT Fellows. And so I'm really couldn't be happier that we've got all three ACT Fellows from 2025 able to join us today in person to share with us their research. I also asked them to think a little bit about what sorts of things they might wish for ATSE to do and what they might want to contribute to ATSE. I'll see how well they rise to that challenge through today. Sorry, I've had to jump roles here. So I think without any further ado, we will move straight to the speakers. Can I say, just in terms of the way the day will, or the event will unfold, is we'll have each of our speakers. We'll start with I've put Rob on first, and then Eric, and then Brad. And if you can hold your questions at the end of their presentations, that would be great, unless there's something really burning that you feel you need to clarify. It would be great if you could hold your questions till after the three of them have finished, because what we'd like to do, and fellow committee member Sue Meek will be joining us then as well, we'd like to facilitate a conversation, both in terms of the things that we've heard from our three speakers, but also anything more broadly about what ATSE is doing, what it means for ATSE, what you'd like the ACT division to do perhaps. So we just want to make sure we've got enough time to have that broader discussion. So I think that's all I really needed to do right now. And so we'll move on to our very first speaker, which is Professor Robert Mahony. And he's going to talk to us today, and you can see the title on the screen, the role of open source communities in research translation. Rather than reading out his abstract, I'm just going to hand over to Rob and he can get us started. Thank you.
Thank you. And everyone's okay? All right, so pleasure to be here, and thank you for the invitation. And obviously I'm absolutely thrilled to be elected into the Academy as well, so I appreciate all of the support. And that didn't work. So I should be able to press a forward button or a... So if I do that, that works now. All right, so I was sort of trying to figure out how to actually talk today. I've got some stuff I want to talk about open source communities later, but I thought since it is sort of a welcome to Rob Mahony talk, I'd actually put a little bit of background in and history. So I'll go reasonably quickly through it. I studied pure mathematics and geology at ANU, and that was before engineering existed. I always wanted to do something for society that was a geology. I enjoy rocks, and I love mathematics. I just love mathematics. That's everything. But then I went and worked as a marine seismologist for a number of years. I never found any oil, but I spent a lot of time looking at those seismology graphs that you get. In those days, they were all printed on massive pieces of paper, and you'd have a big table to lay them out on. And that was a lot of fun, and it's a very interesting inverse optimality problem that underlies it. And I think it was about 9 months into the job, my boss actually took me aside and said, "We don't pay you to build new optimization algorithms, we pay you to process marine seismic data." And so then I went and did a PhD where hopefully I'd find a job where somebody would pay me to build the algorithms that other people would use. So I was lucky enough, and I'll come back to that point later because that's what I think academia should be about. So anyway, I was lucky enough to meet John Moore who was in the department with Brian at the time. And I really wasn't picking a subject. I was just picking a good academic who I thought I could work with. And he was doing work on optimization and dynamical systems, needed somebody with mathematics background. So I was lucky enough to proofread his book with Uwe and get to work with Uwe. And then a few years later in my postdoc, I sort of extended that work a little bit. And that's one of the things that I'm known for. I won't talk much more about that because I did go across and do a postdoc in France. And it was in France when I got involved in aerial robotics. And so I was in a laboratory in France in 1998 that decided to get into aerial robotics. And they bought a robot, which is actually that picture of the helicopter on the top left there. And if you actually look at that helicopter and you're a roboticist, you'll notice that it has no instrumentation, it has no sensors, it has no cameras, it has no controllers. And that's what we had. And so I did a lot of modeling of robots and I did a lot of studying how to control robots, but realized pretty quickly that actually what was needed was some of the underlying algorithms that were just missing. I'll talk about that on the next slide. But later on, I came back to Canberra. I think that should be playing the next video. Yes, it is. So bottom left there is actually at ANU. When I came back, I was into quadrotors. And that's actually the first autonomous quadrotor that was built in Australia. There were actually almost the first in the world. I think we were second in the world. There was ETH beat us to that. And so that was a pretty cool little project. It only flew for 5 minutes, and we only actually ever flew it that one time because the rotors were a bit dangerous the way we designed them. So we learned from that, but then other people were building them commercially. I was working with France and we were working in aerial robotics. So I did this work with Bertin Technologies, which was a company in Paris. So this is in the middle of winter in Paris. And so the battery only lasted for 5 minutes, but it was the first time anybody had done commercial grade equipment, visual servo control. So that vehicle is positioning itself entirely on looking at the two orange dots on the side there with a camera from the eras of 2003, which was only running at 10 hertz and various things. You can see that the control loop is marginally stable actually, but nonetheless it did stabilize and we were very proud of it. You'll see it just wobbling a little bit as it stabilizes there. You can see just the edge of instability in the control loop. I would definitely not give a distinction to a student that produced that controller these days. And then I did a little bit of work again with the French a few years later, so we had slightly better equipment. And this is landing on a moving platform from texture only. So this is using a camera again. It's computing optical flow, and it's using algorithms inspired by how insects land, so using the optical flow to control. But we weren't biomimetic engineers. We were doing real engineering. So, well, I shouldn't say that, but we were doing the old-fashioned control engineering and studying dynamics and everything. So that was the difference that we had. So quite a lot of work in those sort of robotics areas. What actually I learnt from doing these robotics problems was that there was a gap in technology, right? And it was an interesting gap because it was basically how to estimate the attitude of the vehicle. And so when we started doing this, we would talk to people and say, well, how do you estimate the attitude of the vehicle? And they'd say, well, that's a solved problem. The Americans know how to do it. Berkeley's flying helicopters, et cetera, et cetera. And then I'd go and read the transactions of control papers, and there'd be these big long papers about how to try and build attitude estimators and how to tune them to actually work. And then you'd write to the academics and you'd say, did it work? And they say, oh, it only ever worked for the one experiment. And then it broke for whatever reason. And what was going on was that the existing algorithms had been developed by the US military and by US people to operate with the sensor systems that they had available to them. And the sensor systems that we had, similar to that Spark Fun sensor, the commercial grade sensor system simply would not work with those filters. So there's actually a gap in the literature, but it wasn't a gap that people recognized was there. You only recognized it when you were actually working with commercial grade electronics and trying to build things that flew. And that's actually why we flew the first quadrotor, was because we had these robust filters that were actually able to estimate attitude. I mean, I put down in the bottom left there, if you get out by 1 degree, your attitude estimate over a second, you're 10 centimeters, that's okay, you can manage that. But if you can't correct a 1 degree error in a minute, you've crashed. Basically, you're lost. So you're actually, the precision that you need is quite high. And with these very low-grade IMU systems, they're going to develop enough noise to have that sort of error in less than a second. Basically, their gyro biases and everything would grow faster than a second. So we did this algorithm, and it was pretty high impact. It went into the DJI drones, it went into the Parrot drones, it went into all of the drones. So it was essentially the missing ingredient that enabled the drone technology of the 2008. So around about 2000, 2009, that's when the technology came out. By 2010, there was a multi-million-dollar drone industry. By 2015, it's multi-billion-dollar drone industry. So that was quite exciting. And I just went on Google and looked up Mahony filter, and I just pulled down a whole stack of graphics of people that have actually separately done different sort of block diagrams of the filter. So I thought that was sort of cool to see your name on a whole bunch of bits and pieces. So that was a cool piece of work. So anyway, that led us to do a whole bunch of stuff in state estimation. So top left there is the Mahony filter. Then we extended it to a problem in robotics known as SLAM. So this is visual SLAM problem. We extended on the bottom to what we call homography tracking, so tracking images. And I've put down on the bottom left there the shot over camera. So I took a industry project with shot over. They're the company that does all the movie cameras. So they do all of the high performance movie cameras and stuff for the Hollywood. And so they're running the INS, the inertial navigation systems that we wrote for them and such like. So it's had a reasonable amount of impact across that sort of field as well. All right, so to get down to the nitty gritty of the point I wanted to make, this led me into the open source community. So in fact, the open source community was also getting into avionics around this time, and they were looking for observers and filters that would actually work. And they picked up on this work, the same as all of the industry players. And actually the first commercial implementation or commercial open source implementation of this was a filter called the DCM in the bottom right here that ArduPilot developed, and it was actually that code that got picked up by a whole bunch of these companies. The point about what they did was they got it up and running pretty quickly once they realized it was there. And then industry players knew about it, right? And they were able to play it. I'll leave that video running. I forgot to make it run because I'll talk about that in a moment. Anyway, so ArduPilot has it embedded in their code. They've, of course, got different filters running, but I've been working with them over the years. So we've done the work on dealing with GPS lag. So GPS comes in 150 milliseconds later than it's always lagged with respect to what's going on. So how do you actually deal with that time lag? We've done a bunch of work on robust backups and understanding failures of their when the filters go unstable to recognize that they're going unstable so that they can then reset. So we've been working in tandem with the open source community right through. And I guess that's the sort of the message that is coming out of that, is that a lot of this impact that I've been talking about wasn't me directly working with companies. I didn't work with DJI, I didn't work with Parrot, none of these companies. I never sat down with them and said, I'll build the observer for you. I did do that with Shotover, but it was for my sake to understand the industry problems. But through the open source community, the capability got demonstrated. Then industries would say, we need that capability. They would then go and look at the code and write code themselves, but they would read the papers and they would actually consume the research as research is designed to be consumed in that way. But the step from doing the research to getting the industry to adopt it went through this open source demonstrator. And that's one of the messages. All right, so I'll get down to some of the stuff I wanted to talk about. So I guess I wanted to put this slide up because I think people sometimes forget what an academic engineer is. So what is the role of an engineer at a university? So people understand scientists, right? Scientists, their goal is to study the natural world, and their job is to develop models that explain natural phenomenon, right? And that actually pretty much covers most of science and the underlying motivations. And you know what an engineer does, right? Engineering is a place where science meets society. So what does an engineer do? They use science to build artifacts and systems for the advancement of humanity, for the good of society. So an academic engineer is neither of those things, and that's what gets lost. So an academic engineer is using science and an understanding of the natural world. So they're not a scientist, but they're not building stuff, they're building the tools for engineers to use. So they're filling that role to take their understanding of science and build the tools that an engineer needs to then be able to go out and do work. And so there are some industry labs that actually employ what I call academic engineers. And historically, Bell Labs was the big one. IBM, Xerox did. In the modern world, you've got Microsoft Research, you've got Meta AI, DeepMind, OpenAI, Anthropic. So often in these really advancing new technology areas, you'll get industries investing in some of these sort of more research-oriented labs, but mostly academic engineers are found in universities. So this is then poses this question of how do you do research translation? And so I wrote down these principles for academic engineers. So the key thing is that even though you're called an engineer, your job is not to build stuff, right? That's a job of an engineer, right? So my job is to build tools and to enable engineers, but I shouldn't be actually building stuff. Specifically, I should not be doing contract R&D work, right? Because that's when a company comes to me and says, build this piece of kit for me. Now, I do those projects, but only when I want to learn about what the real problems are. So I'll do that project to understand the industry and understand what the roadblocks are. But to actually ask me to do that over and over is just ridiculous. I shouldn't be leading spin-offs, right? I should not be selling IP to industry, right? In fact, the IP that I generate is useless to industry because it's the tools to do what they need, not actually what they need, right? So I shouldn't even be able to sell the IP to industry. And in fact, when I was younger, I've had conversations like this and it didn't connect at the time. I didn't understand. So let me just make the point that that doesn't mean that people can't change career. I'm just talking about when you're in a university as an academic engineer, you shouldn't be doing these things. I'm perfectly happy for an individual to say, well, I've got this cool IP. I want to go off and do a spin-off company. But they shouldn't think of themselves as an academic engineer when they're doing a spin-off company. They become an entrepreneur, right? They become a CEO of a spin-off company, and they need that clarity in their own mind. So the other thing I wanted to say is this doesn't mean that academics can live in an ivory tower and do whatever they want, right? So, academics have an ethical responsibility. We're paid by the nation. We must be contributing to Australian society and more broadly to humanity, right? That's actually our role. Education is part of that. But the research portfolio should be part of that as well. And so, my comment is you should, as an academic engineer, always be working on important problems. So you should be able to describe and understand why the topic that you're working on is of relevance to society, right? And part of that is the last point here, that you must be able to at least express how you can see your work being translated into a benefit for society, right? So this is something I've grown to understand more later in my career, and partly why I'm so clear about my role in working with the open source community, because I see it as one of my main benefits, or one of my main mechanisms to translate my work into society. So open source communities aren't the only way. There's a number of different mechanisms around, and the government obviously has thought about this, and smart people have thought about this. So things like cooperative research centres and this concept of pre-competitive R&D coalitions, I think is what I wrote there, is actually exactly in the same space. It's saying that we need to be doing research work that is close to translation in a way that works. Some CRCs work, some don't. I think when CRCs try and approach it from the point of view of generating IP and selling IP, they've lost the plot. They're not quite in the right space, but there are CRCs that do quite a good job. I'm very interested in this concept of embedded industry fellows, to actually set up schemes whereby industries can send employees to work in academic groups that are relevant to them and interesting to them, and maybe even get government grants to support that. And the university, of course, would charge for the industry person to be in the grant. But there's benefits for the industry that the engineer would still work on the industry problems, but they'd be embedded in an academic group. They'd have a perspective that was larger. And there's benefits for academia because you'd learn more about what the real roadblocks are. And then there's this open source community opportunity, which is the one that's actually sort of driven my own translation work. And so open source communities are a real opportunity for academics, right? As long as you don't get sucked in too much, you've got to keep your mind on what you're trying to do. But open source communities are early uptakers of new technology. So if you have really good ideas, you get an open source community excited, they will implement it, right? And they will do demonstrations. They will get excited by anything that's cool. So a good open source community is super, super dynamic. I mean, actually keeping up with them is hard. That's what I find. I find it really difficult to keep up with them. They're very good at problem solving. They're very good at rapid prototyping. And they essentially come out with solutions that are quick and dirty to interesting and important problems. So they don't solve problems the same way I do because I'm interested in really fundamentally solving the underlying problems, but they do use stuff that's come out of universities in a really powerful way. So I see them as a huge opportunity for translation of new ideas. And I think at the moment in our research infrastructure, they're undervalued. And I'd like to, actually as part of my role in ATSE, sort of help move some of the government dials towards improving some of these other translation metrics. Just to give you an idea of the sort of power of this is the Boeing Ghostbat. And that was all of the test flights were done on the Yardra pilot, so running the code that I've been involved in helping develop. Of course, once they'd done all the test flights, then they went ahead and did proper avionics. But it's that initial quick, dirty solution stuff that's super exciting here. So a bunch of robots that I've been involved with. I'll just mention on the bottom right here is some stuff I'm doing now in the Bushfire Research Centre of Excellence, where we're flying over the Brindabellas. I think actually I might even, oh no, I had the video on earlier where you saw it flying around over the Brindabellas. Pretty cool. So that's again another sort of translational aspect that I'm doing, which is more along the lines of trying to create demonstrators of technology to draw the Australian fire community into what I see as the correct way to deal with some of, or at least a way to deal with some of these early ignitions and such like. So thank you very much for your attention. Thank you.
Thanks, Rob. That was really interesting. And I'm sure, like me, there's got some questions we want to ask, but we'll hold them and move to our next speaker. And it really is, I should have said at the beginning, what a diverse set of talks we've got today. It'll be interesting to see what threads emerge. So I'd like to welcome our second speaker, which is Eric Vanweydeveld. And Eric's background is in water resources, hydrology. He's an entrepreneur, I think, perhaps. I'm not sure. He'll speak to that. He's a director of his own company, Equinox Water Management, and I, again, won't bother reading his abstract. I'll welcome him up here to speak to us because your talk is now ready. Eric, thank you.
Okay, yes, please. Hello, everyone. Thank you very much for welcoming me and listening to me. And thanks, Rob. I do use drones quite a bit, so thank you. It's a bit different than the previous presentation. I am a water engineer. I work across Northern Australia and the Pacific. I move in this space, not by accident, but as an independent consultant. Yes, it was a bit of a journey. And I do work outside of the mainstream. I tend to put the human at the center of all the work I'm doing, and I'm trying to push very hard the government. Like when I say the government, is different levels of governments, federal, but also state and the Pacific governments. And I've got a bit of a few words I would like to say about what I would like to achieve with ATSE, the partnership. But I just wanted to give you a sense of what I'm trying to do overall, and that's coming back to the human aspect, and more specifically like remote communities and First Nations, not just in Australia, but also in the Pacific. Um, I'm from originally from Belgium. I studied in France. I moved to Australia 20 years ago. I came here to learn English, and I did a lot of backpacking, farming across Australia, northern Australia. So I've seen some very remote places. I lived in the NT for 12 years, Alice Springs for 3 years, down Alice Springs, and I've done quite a bit across. Still today, I travel a lot. It's exhausting, but it's very fulfilling. So my work is basically across those 4 components. Like I do quite a bit in remote Australia, in the Pacific, but also I link this work to the R&D project, and more specifically about water treatment solutions and governance with the state governments. Remote Australia, as you know, it's very big, covers a lot of ground, but also a lot of communities. There's some serious issues there that is ethical. Well, it's not ethical, and there's a lot of, and Brad is well placed to explain that. But there are a lot of communities across, but there are also 500 communities that are managed by state governments, and some are not managed. So it's a very complex space. And basically, as an independent consultant, and I see myself as a free electron, basically. I don't report to anyone, but I try to help everyone. I was very lucky to do well, sorry, that's the Pacific. It's another interesting space. There's a lot of different countries with different cultures. The challenges are very similar to remote Australia, but we're dealing, instead of a big landmass, we're dealing with a very, very small landmass. But the challenges are very similar. And I will explain to you a bit more about this. So for 2 years, basically, under the Water Services Association of Australia, I was asked to basically to review the situation in remote Australia. At the time, it was not very clear. A national picture wasn't available. There was a lot of focus on localized issues like in the states and territory, but the association trying to engage with federal politicians, and they couldn't really put forward a clear picture of the situation. So they asked me. That was during COVID. I just started. I had to resign from my job from the NT because I moved to Canberra. And I didn't have much there. I was trying to find my way. And then Wassa said, oh, can you please just do a couple of pages on this situation? Well, the couple of pages became like a big report, 2 years. And it was very challenging to try to understand the situation in those jurisdictions. When I say remote Australia or Northern Australia, it's WA, South Australia, NT, Queensland, and a bit of New South Wales. And then you have that's the on the ground, but then you have the connection to the federal level. And there's a lot of irony in the system. You can see the schematic there. That was important I basically worked with a cartoonist to drive this because it's very unique. And there's a lot of subtleties there that just conveys the situation that is sometimes extreme and out of, if you knew all the details, you would say that's not acceptable. As a general population, you think it's not acceptable, but this level is extreme. Through my working in communities, but also with the different utilities and WASA, I basically came to the conclusion that everyone's trying to challenge and address in somehow water quality, because it's easy to say, oh, water quality or water security, but there's a ripple effect across that in those communities that not necessarily very big. But if those components are not working well, there's a massive replication across. You can see across the schematic there, like health, but also livability, education. So by addressing those 2 components, you can address a lot of different things. And that's the point I'm trying to make with my work. And that's the reason I would like to work with ATSE, is to try to engage more at a higher level to really convey that in a different way. I was talking to someone here about, these different bodies and different organizations doing, well, this is just South Australia. So I spent 2 years mapping the organizations that are involved in those communities. So imagine you are living in those communities, there's a leak in your street. Who do you call? Well, good luck to you, because that's who all the players basically trying to deal with water security and water supplies for Aboriginal communities and remote communities. That's just one, South Australia. This is Western Australia. This is half of the NT, second half of the NT. That's Queensland, and that's the federal government. So you can see there's so many players. There's a lot of deflections, I would say, like us, not me, it's them, or it's never resolved. And it's just ongoing politics. There's so much waste in terms of funding. And the poor people living in those communities have got no idea who to talk to. And then the governments are just doing crazy stuff. They don't talk to each other. They build a water main in the street. 2 months later, they just rip it, put the cables for internet connection or whatever. It's just insane. So that's just an example of one community I worked in Borlula in Northern Territory. Again, I said to you, I was trying to put the human factor into this work. And this was a really good example of how, when you really put the effort and you build trust and take time with communities, you can really change a bit the scenario of just wasting time and then, move on. Here, the issue was I had to manage for Power Water Corporation. I was working for them at the time. A new water treatment plant to address the very acidic water. pH was 4.2, and there was a lot of issues through the whole system. So heavy metals from the pipes going through the drinking water. But what I did here, it's not about the engineering piece. It was more about how do you integrate the engineering with the community and then trying to harvest the power of this community to really look after the system. In the NT, there's a lot of issues. It's very complex, but often when the government delivers something, there's a lot of vandalism and stuff because it's just the way it is. So here, because it was a very expensive piece of kit, and then it was very important to the community, I tried to reverse this situation by involving the school with the kids, and we did a lot of work over 18 months. So it took me a long time to build trust. This is critical. And then from that, I was able to build on top and then trying to make this a success. So the project was to build an artwork with the school and all the people supporting the school, and then asking the kids, well, how do you see water in your community? How do you, but linked to your culture? So there was a long process to get there, build a trust, but also get the approvals and work with the kids. We did a lot of sessions to explain what Power Water was doing for them. Anyway, at the end, I got 30 paintings. You can see them. And then we decided to put them around the site. And it was a big opening. So the community was owning this project. It was part of there was absolutely no vandalism, and the community embraced it deeply, this project. And there was a lot of communication about it, not in English, but also like local languages. And it was extensive work, but it was very important. I can imagine, I can understand the departments that are very, they have to push very hard, very quickly. So they skip all those things. But then at the end, the community pays for the price, and same for the government. So that's why it's not working. Another interesting project is in the Kimberley, is trying to address the water quality, more specifically disinfection. There's a lot of issues there too, because it's very hot and it's remote. There's floodings and carols, and so there's another big piece the Western WA government is trying to achieve there. Sorry, I've got a few slides, so I'll fast track a bit. But there's a really good program in Queensland about safe and healthy drinking water with Indigenous councils. They're really trying to empower operators, mostly Indigenous, to look after the communities and stay in the communities. This program is, in my view, very innovative, and it should be duplicated across Australia. But again, it's siloed, so it's very difficult to try to break the barriers and say, look, and I'm trying to always showcase it, building case studies and things. But this is where the problem is a lot of silos. How do you break that? That's another example of improving water security across Central Australia, but that's also including South Australia with homelands. Same situation is siloed. How do you break that? This is the last work I'm still involved in. I'm moving to more the government pieces, like both the NT government independently in Queensland have the big strategy, but they don't know how to implement that, how to move to the ground. So they asked me to work with them to develop a framework to move from a policy perspective into real application on the ground, how to prioritize projects, which projects are more important than others. Not necessarily say drop them, but in terms of doing what you can with the bucket of money is limited to address a lot of different things. So I've been working a lot on this. This is an extensive piece of work that focuses on, do you remember the ripple effect graphic? The water security and water quality, that's the center, which is the blue box in the house system there. But then what I'm trying to integrate here is the human aspect and the community aspect by moving towards away. So the hardcore is pretty easy. If you look at water quality, you know, Australian drinking water quality guidelines, black and white, easy. The more you move away, the more it's hard. And I said to those two governments, is with the money you have, which is limited, how can you improve the whole ripple effect? And this framework is designed to do this and looking at different perspectives, health, livability, you know, employment, all those things. And it's trying to challenge their thinking. I think it's moving forward, but it's very slow. In terms of R&D, this is developing a new technology for removing nitrate. It's a big issue in Western Australia and ENT, but also in Queensland. So I've been working, I'm a project director to try to coordinate all those organizations there to produce this technology. It is very difficult, but we are moving to the beta unit, which is full scale, and we're trying to deploy that and to really harvest the data and improve the technology. And there's a lot of processes because we're dealing with water quality, so human health. In terms of the Pacific, I work mainly on a few nations, but one is, in particular, it's Kiribati. I don't know if you know, it's north of Fiji. It's you can see the photo there. It's very very limited, is overcrowded. There's 70,000 people living there. It's extreme conditions, but very similar to the First Nations in Australia. The food is delivered by boat, frozen. They don't have access to fresh food. It's very challenging. Water quality is an issue, but here I'm mainly working on sanitation. There's a lot open defecation is a massive thing. So there's pollution across the board. The kids are dying very young. So here I work for the World Bank, and basically this project is about delivering a new solution for sanitation, so septic tanks and toilets and stuff to operate underwater, because those islands are 1.8 meters above sea level. You can imagine in 20 years will be flooded. So this work is all about how can you use materials from the island, which is tires and old drums and stuff, to build septic tanks that can operate in the water. So it's very challenging, different perspective, but the thinking is very similar. You can see there's a lot of, again, the human aspect is very, very important. I'll just skip a bit. That's just in the Pacific, they call it the sheet flow diagram, sorry, but that's the name, where we're trying to map all the waste flows across the different streams. So I think that's it. But what I wanted to say to you is what I'm trying to do, and it's very difficult every day, but you can see there's a lot of similar issues. Everyone operates in silos. And I think what is very important is to have united voice. And I think Brad and I worked on the ATSE position statement like a couple of years ago to really try to elevate this issue at the federal level. A lot of politicians and bureaucrats don't understand the situation on the ground in remote Australia. And it's easy to say, oh, we spent 100 million here, but the money doesn't go to those communities. That is just wasted across the system. And you could see those schematics. So this is where I would like to work with a group to try to convey that in a different way, and to also provide some funding about R&D research in this space, because those technologies we're using everywhere in Canberra or Sydney are not designed to operate in remote Australia. Then we need to develop new technologies that are very specific to those communities. And it's possible, but we need funding and we need support from the government. Thank you.
Thanks, Eric. So many lessons there for implementation, working with communities. Yeah, that was really interesting. Thank you. And a nice segue to our final speaker. So it's really good to have Professor Brad Moggridge here today as well. And he'll continue, I think, on the water theme as well. And so Brad will be talking about the challenges of being what feels like a lone voice for Indigenous knowledge in water and climate. And Brad is with the University of Technology in Sydney, and I know it's going to have a very stimulating and interesting talk as well. So Brad, the floor is yours. Thank you.
Might be a bit depressing as well. Just about. I can't sing either, so I'm not going to hold the floor. There we go. Just the arrow.
Yeah, it should work.
Yeah. Thanks, ATSE, for the opportunity to have a yarn about what I've done and doing and hope to do. Rob, I did start in geology. Love my rocks. Year 10 to year 11, I was told I shouldn't do science or maths. They allowed me to do geology and biology, and we used to call it maths in space. Was the basic maths back in the day. And then ducks of geology, year 12. And then started geology at UTS in the early 90s. And first year science maths, I didn't know what calculus was. Yeah. So I suppose that pathway, and then to science was it took a while, but it got a tutor, and he was the head engineer of the Harbour Bridge back in the day. He lived in Winston Hills, Western Sydney, and I went to a few of our little tutorials in the north tower of the Harbour Bridge. So that was cool. Look, I think then did geology, was looking for uranium in a national park in the Great Sandy Desert, and I thought, I don't know if this fits too well. I love learning about the earth and I love my rocks, and changed to environmental science. So that was the pathway to science. It's my boy getting smoked. He was quite tasty after that. Eucalypt. No, that's him at an event. He's a ranger now at Ginninderry, just over on the Murrumbidgee. So he's doing some cool stuff over there, loving his work. Nearly 22-year-old with his dream job. Yeah, like not many people. He was an academic. I think he got his name right in the HSC, but that's it. He's found his path. This is who I am. Some old photos there. Kamilaroi country. Want to acknowledge Ngunnawal country. I've the pleasure of living on Ngunnawal country for the past 16 years, and loved my time here. The kids are grown up. The daughter's now doing Bachelor of Archaeology at uni, first year, and as I said, the son, he's a ranger. So we're all sort of in the dirt, rocky, watery space, which is cool. I think the ancestors set the platform for me to have an opportunity in life. So Gali is our Kamilaroi word for water. It's in everything. So you got to think we're the driest inhabited continent on Earth, and without water you die. So it's pretty important. It's in everything, especially, Eric was talking about some of these remote communities and their water quality, but their traditional knowledge of their water wouldn't be considered. At the moment, definitely my privilege is I try to speak truth to power. And sometimes those truths are uncomfortable. If I get people squirming in their seat, that's good, whether it's government or whatever. It's an opportunity, it's a platform I have. And I'm trying to reconnect as well with some of my own traditional knowledge and methodology. So I'm still learning. That snake, Morelia spilata, is the carpet snake. So that's the last totem that was given through through generations, through my grandfather. He sits at the front door, and hopefully he zaps all the nasty spirits that come in. Look, that's a map of Australia. Robert Zook's Grasshopper Geography, I think his name is. And you can sort of see the complexity of Australian landscapes in that photo. Like these are all the river systems, the Murray-Darling, bottom right, the Aqua, the Lake Eyre Basin, you can sort of see the yellow. But you move away from the coastal areas and the city centres, and if you don't know where water is, you're going to find it tough. And I think that adaptation to a dry continent, knowing water, surfaced and groundwater, if you don't know it, you're not going to last long. And I think to have some of those nations, 60 odd thousand years of surviving on this landscape, but we don't celebrate that as a country. This is 101 water policy. And I suppose where I'm sort of trying to do what I do on how to influence and have impact where I can. We don't have a voice, we don't have a treaty, we don't have very rarely truth and no veto. So we're the only colonised modern country without a treaty with its First Peoples. So it's a big challenge. And obviously my mum's generation was grew up on a mission in the early days. And obviously my grandparents as well. Every move was controlled. And they moved, grandfather was with the railway, so they moved around a lot with building the whole northwest of the railway systems. There's a story in that. A lot of Aboriginal men back in the day, and they were on country, they were connecting with their land, but also, they were building railways. And obviously it was one of the reasons why the mum's one of 14, so none of them were taken. So it's one of the good reasons why, he was working Nan's tin humpy or tent, whatever railway tent, the dirt floor was spotless. So those sort of things, the mission managers are always looking at. So, and then in the late 1960s, mum was counted as a human for the first time, and she would have been 27. And I suppose 17. And yeah, that sort of thing changed. And then when we became human and emerged from the missions, all the good land and water was gone. And then you move to the 2000s and we had huge water policy reform, and we saw land and water decoupled. Originally they were together. If you had land, you got water. And if you wanted more water, you just got it. And I suppose that was the Murray-Darling Basin cap that come in. And I suppose that tried to put a sustainable yield on top of, on top of the system, but it never worked. And I suppose the thousands of kilometres of blue-green algae was the big reform change. And then obviously all the reviews, the National Water Commission back in the day, now the Productivity Commission, just telling us what we don't have. So I suppose that's the fight. And then of course, if we are able to get land, then you have to go to the water market and buy it. So it's, win-win. What I'm trying to do is shift research from Kamilaroi people as the researched to become the researcher. So it's a bit different. And I said, that's my privilege. I've gone through the educational system, Bachelor of Science and environmental science and Masters in hydrogeology, and then a PhD in pretty much the water space as well. So I suppose that's sort of been my pathway for the last 30 years. And, I'm still learning. I want to fill that void. There's an opportunity for Indigenous people to enter that space. They've got to have some courage to enter that space. And I suppose part of that is education, but also it's infiltrating that system as well. I did a little project with CSIRO. We'll fund it until 2028, and CSIRO has some issues, a lot of issues maybe, and we got defunded 30 June 2025. So we were working with 2 Aboriginal communities looking at what their cultural indicators are, talking about drought. And I suppose the idea was then that knowledge could then influence drought policy. But I suppose in the end, all we could do was do a report, give them a huge database with all their indicators and walk away. That's our integrity on the line. And I suppose big beasts like CSIRO they don't care. They don't care. You know, that's our issue. And so, yeah, from 2025, been chasing the dollar. There's no money. You miss out on an ARC. I've given up on ARC. That's strike 6 for me. That's been part of like CRCs and Centre of Excellences. And so I suppose philanthropic, there's not much money worth fighting. And every researcher knows that. Every researcher, it's not just me. So this is one of the projects we did out at Dharawal, while back at Lightning Ridge, in between Lightning Ridge and Walgett, the Narran Lake system. So we saw it a number of times over the years at its absolute best. You know, the big mob of emus, pelicans everywhere. Like, I think at one point they had like 10,000 breeding pairs of pelicans. You know, just when you add water, goes nuts. And there's obviously artifacts everywhere. This landscape is very important to the Uluru, and I suppose they're part of its management now, which is great. That's a little diagram we turned. Max Fabilla was one of the young project officers we got on. And yeah, he had connections to arty-farty people, which was cool. And he got us to drew us a nice, you know, it goes in circles. A lot of our stuff goes in circles. It's a bit like, you know, adaptive management or things like that. But this system is about checking in all the way and making sure that the community was at the core. So we had community leading, guiding us on the research question, on where the project was going to happen, when we're going to meet on country. And the challenge was for ethics, as we didn't know what the project was going to be until we could talk to the community to co-design it, but we couldn't talk to the community until we got ethics approval. So ethics has to evolve as well. So that was the challenge. We got there in the end, but I think it was, the other community was Gungaloo, which is west of Rockhampton in North Queensland. And they're a completely different scenario. They have a 1880s gold mine, acid mine drainage. Their river is bright orange. And they've always known it. They've swam in it. They've been part of it as kids. They called it Copper Creek growing up. So I suppose those challenges are completely different to what Narran has. But they still have cultural indicators as well, which was cool. Bit of groundwater stuff. So yeah, like did my master's in 2005. And then in 2020, published my master's. So don't give up on that paper, I tell young kids, or early career researchers. So Emeritus Professor Angela Arthington offered me an opportunity to publish my master's in, they did a Springs of the Great Artesian Basin special issue. And yeah, my paper's there up the front in paper number 2. So that was quite an honour. Was part of the Australasian Groundwater Conference group, and we had an Indigenous groundwater session. And in the lead up to that, IAH was the International Association of Hydrogeologists. They have the thing called the Sao Paulo Declaration, and it's very motherhood about protecting groundwater and all that sort of stuff. So I thought, why not do an Indigenous one? And had the support of the then IAH Australian president and the conference president. And yeah, we come up with 7 articles and we put it online, and we had a nice breakfast with mining companies and whoever else, hydrogeologists that were there in Perth. And you could sign that declaration. So I'm not sure if it's still live. It crashed a bit. I was getting $1 for every signature. No, I wasn't. I wish. No. But yeah, it was more about if you connect with that declaration, you connect with those articles, sign it, and try to live by it. That's all it was. So, I suppose I talk a lot. This is that part of this is about walking it. I was honoured to do 2 special issues: Australasian Journal of Environmental Management, Indigenous co-lead authors, Australia, New Zealand, an abstract written in an Aboriginal language. That was probably huge for that. The second one was with Catherine up the back, and it was a challenge. Yeah, we got there in the end, and myself and my then supervisor Ross Thompson, we won the Jean Alexander Medal, and through the Engineers Australia, because they sponsored the journal. And then I suppose, sorry, but engineers are very petty. Because we weren't engineers, we didn't get a medal. We got a bit of paper. And the big one at the bottom there is that we got Martawarra River of Life as a first author. You know, that was huge. Yeah, for a journal, and obviously the chief editors. So we got that in as a first author. It was obviously Catherine did a lot of pushing the editor and back and forward. In the end, they were solid. You know, they were very supportive. So Martawarra River of Life is now, you can quote it as a reference author. More walking. Sorry, yeah. This was about building a methodology on Kamilaroi country. I went to New Zealand. I was lucky to go to New Zealand. Got an Australian Academy of Science award to go over to NZ, and got to try and learn some of the tricks of the trade. And I was presenting at one of the Waikato River Conference, and I followed the Deputy Grand Chief of the Cree Nation, and then it was just Brad Moggridge, like a researcher from Australia, and he talked about they're just negotiating a $5 billion settlement with the US government. So, and I said, we've pretty much got $30. Yeah, that's it, if that. And they'll ask for change. And then obviously that last paper was with Ross again, and it's in a book and 18 chapters. Oh no, sorry, it was 22 chapters. And yeah, it was actually about talking about how we actually delivered on that methodology, turned it into practice. Water quality. So these are the contact water quality guidelines. So primary, secondary contact. I was part of a joint steering committee in 2009 and published some work. So I was like an Australian Indigenous delegate, and there was a Mahony from Te Arawa. And we always said to the committee that we would never approve, as from a national point of view, Indigenous people's input into this. We would get our own sign off from our elders and his iwi, and then it's up to the government of the day to actually then go out and consult on it. So yeah, we were never put in that position, which was great, and they understood it. It's in 2018, it was published, and someone messaged me on Facebook and said, "Oh, congrats on the guidelines and the principles." I said, "Oh, are they out?" So the government just launched it, didn't tell anyone, and they're just there. So they're still not being used. Yeah. So we come up with 9 principles, and there was a lot of crossover between Australia and New Zealand. So went over and caught up with Roku in Wellington and some of his elders or iwi, and we got to talk about some of these challenges that we're facing, and it was really cool that the crossover was there. And then we actually had some of these principles that, when you're building a water quality plan, think about these opportunities for cultural and spiritual values. So that they are live under the Australian government website, under water quality. They're there. Oh, I better get moving. Climate has changed our landscape, definitely. So this is on my country. This is Gingham Waterhole in the Guida wetland system. And I don't know if you can see the white sort of boom on the left floating on the water. That was October 2020. That's my son walking across. That's one of the bigger water holes in the complex. And he's walking towards that boom. It was a water hyacinth boom. And so I suppose there was no new inflows, extreme heat. So, you could sort of see the impact of a changed climate there and then. These are just some aspects that have been coming across, contribute the least, but are impacted the most. Some of the challenges also is that Indigenous people are adapting now. Kiribati, they have to adapt now to survive. If you do not adapt, but the challenge is there's no Indigenous scholars recording that and working with them to talk about how they're adapting and what they're adapting to. So that aspect of adaptation is that they're doing it now without any assistance, but they're trying to survive But yeah, like when I did the SOE in 20, well, it was published in 2021, lead up to the SOE, there was no cultural baseline data. No jurisdictions looking at it, funding it, collecting it. And that was, I did the inland water chapter, and that was across a lot of them. Yeah. I'd love to map climate dependent groundwater and culturally significant entities. That's here, but we don't have a baseline. We don't know the state of country. Understanding adaptation more. There are stories of surviving sea level rise from, the last ice age. So survival's built in. Push the implementation of the 2024 National Science Statement priorities, pushing the government and the chief scientists. He was at an event not long ago, and he sort of said, I have no voice and I have no funding, but I'll just do it as I'm told. I suppose that's a challenge, but his job will be to make sure is that the National Science Statement and priorities are implemented. COP31, unfortunately, Australia didn't get it with the Pacific. So it's in Turkey, but I think Australia is the president. So I don't know how that's going to work. But the current situation in the Middle East, who knows if Turkey will happen anyway. And then another one that potentially might not happen is the UN Water Conference 2026 in the UAE. So that may not happen either. Yeah. Yeah. So I was lucky to go to the 2024, and that was the second UN Water Conference in 40 years. And this will be the third. So I'm not sure how that's going to work. Got a little piece in Nature. So that's always a researcher's dream. It was only a correspondence, but I suppose, we had a limited space, limited words, and it was per character at that point. So it was quite tough, but, putting Indigenous voices around climate change is important. And yeah, that's what I've sort of been trying to do. My path today is carry on as Associate Dean at UTS, make the most out of being a Fellow of ATSE. I'm keen to make sure that what I'd like to see from ATSE is, integrity, all the big ones, trust, truth-telling, safety, like I published in The Conversation a fair few times, and the conversation has to then turn off the comments because you're talking about Indigenous knowledge. It's that racist. So the conversation, and then I publish with non-Indigenous scholars, and they're just going, what the hell's happening? I said, that's normal. They'll turn the comments off soon. But I suppose that safety of being exposed, is important. Is important. Obviously, there's the Academy has a fresh reconciliation action plan. I'm always looking at RAPs and making sure they're not craps, but also making sure it's also making sure I watch what happens after acknowledgement of country. Is it just tokenistic? Are they just ticking the box to get through it? A lot of companies do that and they get away with it. But I suppose what can the Academy do in that space? You like this one. I got appointed as a mentor on the Geordies Resolution Academy. Fire to Flood, it was called. It was going to be Fire to Ice. It was the International Ocean Development Program. Yeah, and I was on, people will call it a cruise, but it was a research vessel, 402T, and it gets better, but we were cruising from, voyaging from, we flew to Napoli in Italy, then got a tour of Mount Vesuvius from one of the Italian geological survey, and then did obviously Pompeii and things like that, jumped on the ship and 2 weeks at sea through the Straits of Gibraltar, north up the Atlantic, and stopped at Amsterdam. So and we were looking at ocean core that's been drilled. We got to see the KT boundary, which was cool. That's, if you don't know, that's the boundary of the big meteor that wiped out the dinosaurs, and we're looking at that boundary. And, you know, there was Indigenous kids from North America, mostly North America, 2 from Australia and 2 from New Zealand. So it was quite an honour to be going on that research vessel. Currently in the thick of being appointed as a lead author for IPCC's Assessment Report 7, Working Group 1, Chapter 10. The only Indigenous Australian, but, you know, I'm in Chapter 10. There's a young Indigenous woman in Chapter 1 of Working Group 2, and there are Indigenous people across the 3 working groups. So there's a bit of a network. So it's grown from having none or maybe 1 in Assessment Report 6 in 2023. And even the lead up to Assessment Report 6, Indigenous knowledge was mentioned once, and lead up to Assessment Report 7, there was 18 mentions of Indigenous knowledge. So the IPCC Bureau is moving in that space, which is great. Yeah, that's it. I'll be in Santiago in April for LAM 2, so lead author meeting 2. There's acronyms everywhere. We've just finished the ZOD, zero order draft. We're heading towards a FOD, first order draft. And we have BOGs, which are breakout groups. Yeah. I think it's only the Aussies that are chuckle. yeah, in the thick of it. I'm the immediate past president of the Australian Freshwater Science Society. As I say, my 6-year sentence, it will be up at the end of this year, but it's been amazing. They're a great society. 2 years as vice, 2 years as president, and 2 years as immediate past. So it's a fair commitment. I was lucky to get an honorary membership of IAH at the World Congress last year. Just scored the Aboriginal and Torres Strait Islander Scholar Medal from the Royal Society of New South Wales. So that was quite an honour. So I had a nice little shindig a couple of weeks ago, and my dean was there. So I had my 2 bosses, my wife and the dean, which was cool to celebrate with them. Being a member of the Wentworth Group of Concerned Scientists is a great honour as well. But I do think, because I used to bag out the Wentworth Group online a bit, saying, you know, you can't talk about Indigenous issues because you've got no Indigenous fellows, scholars. And then they thought, we'll shut this fella up and make him a member. No, it's a great honour. And then, yeah, Tegan Shields, she's also from Arabunna, Western Australia, and she's another scholar that's part of the Wentworth Group, a WWF governor and Indigenous advisor, and also New South Wales EPA board member. What I'm trying to do is I'll keep publishing with Indigenous knowledge as evidence and impact. I suppose if it's peer reviewed, it's gone through the system. So I suppose it's then opportunities for government to consider it, provide a safe space for any new generation of Indigenous scientists, aim for global Indigenous groundwater declaration. Next year will be in Mexico, so that's a chance. Can you continue to report on and adapt to a changed climate, and obviously giving a voice to Indigenous people. Keep turning up even if you're tired. So I suppose that's something that I pride myself on, is that you just keep turning up. If you don't turn up, no one will know the story. Yeah. I'd love a commissioner for country under the EPBC Act reforms. I don't think we'll get it. Just imagine an Indigenous chief scientist, and of course push my list of demands. And these are my list of demands. Knowledge and science, Indigenous peoples in the curricula, so starting from young age all the way to the top. First Peoples Ranger and Scholar Network, First Peoples Centre of Excellence for Science, funded research, led, authored by First Peoples, because that bucket, there's no buckets. Yeah, so it's really tough. First Peoples Strategy for Science, Water, Climate, allowing for truth-telling, and a global First Peoples Declaration, which has an Indigenous commissioner. These are my river selfies as the beard grows. A couple through COVID there. The Guida Wetlands, Birrarung in Melbourne, Shoalhaven, the Barker in Western New South Wales, the Guida, and that's the Waikato below the last hydro dam. And then that's a selfie with Vesuvius's caldera. That's my favourite at the moment. Thank you.
So thanks to all of our three speakers for sharing your career, your stories, your yarn with us. Really interesting, and really appreciate that. And I'm now going to, so thank you so much. And I'm going to hand over to Sue to facilitate some questions and answers. And Luke, if I want to see the online questions, where will they be? Because I'll help Sue on those.
They'll be here.
Okay, all right, cool. Sue.
Thanks, Helen. Well, I think the expressions of these three new fellows would have probably got a fair injection work that ACT you could just do right now without even any of the other things that we're trying to do. But I'd like to throw the floor there for questions, and also for anyone who's listening online, the pretty stimulating ideas that we're throwing around for a little while. I ask for any questions anybody would wish.
One thing that has become apparent over the last 5 years in particular is that the cost of solar power provision in anywhere, remote areas or on a rooftop, has become extraordinarily cheap. And if you've got effectively unlimited quantities of extraordinarily cheap energy, how does that change the water equation in myriad different ways?
Happy to go. It's not that easy actually, because the cycles are, that's all about cycles. The sun is up, so unless you store with batteries.
We'll store with water. But you run whatever process you're doing during the day and then store the water instead of the electricity, so to speak.
Yeah, but in those communities, it's pretty small. An asset costs a lot of money to build and to operate. There's also issues with water quality, the temperature. Like there's so many factors playing into this that you cannot go too big or too small. It's a very tricky bit. There are some possibilities, and I think this is where the revolution with AI to try to optimize systems and work out in different ways will add a lot of value. But at this stage, it's the different cycles are not aligned. I'm talking about in those small communities, not talking bigger than that. It's not with this R&D project I explained, we're looking at this, but the cycles are not aligned. So there's a lot of work to be done behind the scenes to align that.
But that's what it's stored.
Well, yes, but the problem is like you don't get funding in those communities to build big tanks. So this is the issue. Like,
yeah, one of the challenges, I did a report for the EPA when I was an officer back in the day, turn of the century, early 2000s, and the challenge with some of those concrete, mostly primary, sometimes secondary treated systems, is that Department of Public Works comes in, builds them a system, and then goes away. No, and they might train one person, and then they leave because they've now trained in something. They can get a job at the council or something like that.
That's it.
And there's no one left. Then you've got pretty much raw sewage going back into the environment. But the other challenge is load, like cycles, but also load. So some of these remote communities might have a grand final and the population might triple, or they might have a funeral. And again, that'll be the same. Or the communities that moved for that grand final, that community's empty. So there's no load. And that sometimes if they're bacterial type systems, they won't be sufficient enough to work. But, I suppose that's got to come into modern day thinking. Yeah.
and there's also the demand, but there's also the leakage. There's so many factors that plays into this. So yeah, the technology is improving, the energy is becoming easier and cheaper, but the whole needs to be integrated holistically, and it's not there yet.
Your comment about silos comes into to mind here, that the people who are thinking about that would not necessarily be the people who are decision makers. Yeah.
This is where the issue is.
My heart bled for you when you put those diagrams up last night. Did you have a comment? Or no. John, do you want to comment?
And can I just say, if speakers just speak loudly enough so that the people online can hear you, that would be great.
Yeah, I think so.
Oh, congratulations on 3 fantastic, rather complimentary in some ways, presentations. That was really good. Eric, I was just struck by one of your 4 boxes was the Pacific. And I'm a member of the International Strategy Group of the Academy. And we have a plan to develop a Pacific dialogue. And so I just have a sense that we'll have some more conversations about how to move ahead. But a Pacific dialogue, it's a natural to listen to what you'd like to do. But a question I'd have actually to Brad is, why wouldn't 65,000 years of knowledge from here be also part of that conversation in the Pacific?
I suppose, I've sort of travelled a fair bit. Like New Zealand, they acknowledge, you know, they've been there 8 to 10,000 years, and I suppose they acknowledge Australia's Indigenous people have that connection of that long time. They have stories going back, you know, how they got there and their canoes, their wakas, and, you know, that potentially the same as some of the South Pacific islands, you know, how they moved, you know, at certain times of the Ice Age cycle. They will have connections to their own land. They will build up that observation, and I think, but how can we use that observation and that knowledge? Because in a science sense, it's not seen as science, you know what I mean? So how can science evolve to start thinking about some of these methodologies, some of that knowledge, some of that observation that's been through multiple ice ages, it's been through, there's even stories of volcanic activity, you know, and that happened 37,000 years ago, volcanic activity. So that knowledge of experiencing your traditional land, knowing your traditional land, but having no say in it, that's the challenge. Yeah.
Opportunities there.
Oh, there's definitely opportunities. Yeah.
I'd just like to congratulate you three on as John said, a wonderful presentation and a welcome, and it's great to have you part of the Academy. I was wondering just a technical question with regard to the development of the technologies you had, John. But is that the battery technology that went along with it must have been important?
It is important.
You said when you started, you had an hour.
Yeah, a lot less than that with the bird time. 5 minutes. Yeah, 5 minutes. That was in -4 degrees. So things improve, you know, when you hit it. It is. So battery technology is a big deal, and obviously there's a lot hanging on it. It's one of those things where you know that battery technology is improving. And I mean, I know with Andrew as well, he models into the future and you sort of know where you're going roughly. It's the same with autonomous cars now, right? So, you know that those cars are going to have ranges of 600, 800 kilometres in 5 years, right? And so I guess one of the points I'd make is, you know, our job as academic engineers isn't to design for today's technology, but to design for 2030's technology and 2035's technology. I always think, you know, as an academic engineer, you should be looking 5 years ahead, 5 to 10. Maybe as a scientist, you're looking 20 years ahead.
Academic engineer
Designing batteries, of course, yeah. And I respect what they're doing, and I use the latest batteries that they give me. And then I argue that capability will be there in the future, right? And it's really a question of knowing enough about the different technologies to be able to make educated estimations of what's going on. So when you're developing technology for applications in, so, you know, for instance, there's applications in cooling towers and stuff where you fly down inside and you monitor pollution, you monitor cracking and stuff like that. You know, you'd have to be able to fly in certain conditions. So you think about sensors and batteries and all that. So different sort of applications, different processes. Yeah. So batteries aren't a big deal for me, although the difference in how much weight you have to put on board has been an interesting thing that we've been dealing with. Yeah. So the bushfire stuff, sorry, I should stop talking, but the bushfire stuff is interesting, right? Because we fly battery powered over the Brindabellas for that. And so even in the time I've been doing that project, which is 2.5 years, we've gone from an hour and a half, which gets us out into about half the Brindabellas, to about 3 hours. So, you know, suddenly we're able to actually fly at night right out into the Cotter Valley and look down the sides of the valleys for the ignitions at night. Yeah.
just a follow up if I could, no?
Yeah, they're right. Quick one.
Where's Australia going to maintain its role in that drone technology and the sorts of areas that you've got? Are you confident that we'll hold our own, or will we go to the back of the bus like we usually do?
Gee, how long do I have to answer this question? So I'm naturally optimistic. I think it's important not to get too down. Australia has this ArduPilot open source community is sort of Australian, right? So it's an international community, but one of the lead developers is a guy called Andrew Chidgell, who was in one of the pictures actually in my slides, and he lives in Canberra. There's a guy in Melbourne, Paul Risborough. There's a guy in Adelaide, Leonard Hall. So these are three of the top players. There's also some people in Japan, not as many in America for various reasons, some Europeans, etc., etc. So that's a facility that's there, and it's definitely integrated into Boeing knows about it. Lockheed Martin, the new ATS or whatever. They we talk to the people. It's that interplay between those companies and such like. So I think there's quite a healthy sort of space there. Then in drones, it's a commodity. There's a lot of commodity engineering in drones. And so then I find it hard to see how Australia can compete with a manufacturer like DJI, where the manufacturing cost per unit is so low in China and such like. And so that sovereign capability to build commodity electronics and commodity robotics in Australia is something that I don't understand how to become.
This is solar cell story all up again. Rob, you have a question?
Just actually, I welcome a focus on open source communities for research translation. Could I just ask though, an area of great difficulty in my background, my experience has been the point where open source stuff gets captured, taken out of the open source, it doesn't contribute back. So it's the boundary between open source material being captured and closed off, and how that prevents or was a break on open source. Is that part of
Yeah, absolutely. So I've thought about this quite deeply. So the key issue here is if it becomes a break to the open source community, right? And so then open source should run with these licenses like GPL and such like. And GPL, for those that work in that area, is a license that means that if you directly take and use the product of that open source community, you have to contribute that changes back into the community, right? So that's an important part of a good open source community. And then the independence of the people in the community and the fact that they can keep doing what they're doing. What you want is that community is like a demonstrator for your industry. So you can see what's possible there. They might use some of the code, but similar to the example I gave, the right way to do that is then when you say, okay, then I want to build a product, you do it yourself. But you know how to do it because you can see it being done, right? The trick between open source and this enabling of research translation is it sits between a researcher. It's an early uptaker. It creates the demonstrators. But you don't ever want industry to be able to buy, you don't want industry to buy academics' work. You don't want industry to buy open sources work. Their job is to build it, but you do want them to know what to build. That's what I'm saying. Yeah.
We're so I think this, I certainly have several questions on Rebel because people up afterwards, but I think rather than let the time run off, I'll hand back to Helen.
Yeah. Thanks. So yes, I feel the same. I've got about 8 questions running around in my head, but I'm reluctant to take us too much longer. So I will wrap up, and I want to wrap up with a couple of comments. I think the Academy is so fortunate to have you three join us. I mean, we've got a wonderful fellowship in the ACT as it is. I think we've got 3 fantastic fellows joining us. And I have to say that in my head, and excuse me for riffing here, but listening to your 3 talks and thinking about the connections between them, I just thought if we had some funding, there's some amazing projects that we could do that combined your technology, Rob, your insights, Eric, into how to work with communities and people and how you implement stuff on the ground. So it actually makes a difference. And your deep knowledge and insight, I was thinking, wow, could we develop some technologies to make life better for our Indigenous communities and rural communities, full stop, in Australia? Anyway, I'm not going to task you with that. I don't have big bags of money to give you that research project, but I'm just saying it as my thinking about what you're bringing to the Academy in terms of your experience and insight and knowledge. So, really thank you for taking the time to share that with us today, and congratulations. And I think we're really lucky to have you on board. And I guess a couple of the things, the threads that I really picked up on actually, which was a surprise to me actually, but it's so important, is community, whether that's open source communities for research translation, which I'm really interested in, because as some of the people in this room know, some of us are thinking about how we can do better to overcome some of the deployment barriers that we have for rolling out renewables and a few other things. I'm thinking, what can we learn from your experience there, Rob? So that kind of sense of community, but the other one, which is people-centered communities. And that's another kind of translation, isn't it? But it's a two-way, and it has to work. So I think for me that having people and community at the centre of our technology was one of the things that kind of connected your talks together. And I really appreciated that because it made me learn something that I didn't know about. And with some of the work that I've been involved in over my career, I am aware of the importance of Indigenous knowledge to understanding how we can adapt to the changing climate that we're in, Brad, and water and climate. The two are so closely connected. And actually of all the continents, Australia is one of the ones where we can share with the world knowledge about that connection between water and climate, because they're so coupled. And I hear you, and I really would value being able to bring that knowledge to Western knowledge better. And I used to help run the project called the State of the Climate. Some of you might know it, CSIRO and Bureau product every 2 years. And I set myself the challenge, which I never met, which was, wouldn't it be great if we actually had a State of the Climate that included Indigenous information? So it's still a dream, haven't got there. But thanks for sharing that with us. And I share some of your aspirations there. I hope we can continue to do better. I totally acknowledge how constrained we are in Australia at the moment by the level of investment. So resources, dollars, but it's people as well. And we have to have skilled people across the diversity of knowledge systems that we're talking about. Yeah, exactly. And I'm going to finish actually with something that you mentioned, Brad, about what you want of ATSE and your points about integrity, trust, truth-telling, safety. And I was so struck by those thoughts, and it's so important for us as a fellowship to be thinking about that. So I hope that demonstrates that I learned something today, and I think our audience did too. So if we could just join together again, thank you. We're over time, and I don't see anyone online asking any more questions. Oh, 1 minute. Oh, well, then. No. I just wanted to let the fellowship know that we're overdue from a newsletter from the committee, and it's in production. So that will come out in the next few weeks. And so I'll leave you to read some of the stuff in there, but I did want to do a shout out about the awards. ATSE awards are open now, so be thinking about your community and whether there's people that you can nominate for those awards. And the second thing I wanted to say, which will be in the newsletter as well, is please don't be shy about approaching me or any of our committee members or any of the professional staff here. If you've got an idea for a webinar or an event or a thing that would be of benefit to our division here in the ACT, we've got very open minds for ideas. And today in this meeting, we've got committee members, we've got Sue, myself, and John had to leave. So there's some faces that you know, but yeah, look forward to hearing from you on that. And I will end there. Thank you all very much. And thank you again, Rod, Brad,
Thank you.
Eric. Yeah.
Oh, all right. I really enjoyed both your talks.
Yeah, no, that's
Super.
that's fine.
You guys are really congratulations.
Oh, thank you.
Yeah.
Yeah. Interesting. Cool.